Hi, my name is Matthew, and I'd like to give you a short lesson on one of the earliest examples of a theorem in geometry, Thales' theorem. Now, all theorems in mathematics have proofs, which means we know the theorem is true because it follows from other things we know to be true, and I think proofs can be pretty interesting. So what I'm going to actually do today, what I'd like to do in this lesson, is walk you through the proof of Thales' theorem. Now, what Thales' theorem actually states is that any triangle inscribed in a circle with one of the legs of the triangle being a diameter of the circle is a right triangle. And that's kind of a mouthful. I don't expect you to understand it without a picture because it's geometry. So I've drawn a picture. I've drawn a couple pictures here. And these are all examples of the sorts of triangles I mean. So here we have A to B to C, a triangle. And you can see that this line here, A through C, goes through O, the center of the circle. And what the theorem therefore states is that any triangle that has that property where one of the legs goes through the center, so is therefore a diameter, then this point here would be a right angle, so an angle of 90 degrees. And it doesn't matter where this third point is. It can be anywhere on the circle. So I've drawn two other examples here. It can be at this point on the circle, or it can be this point on the circle, or it can be anywhere in the circle. Has to be a right triangle. And that's not obvious. You can't see that just looking at a circle. It doesn't necessarily make sense, and you might not even believe it. But it is true, and we know it's true because we can prove it. And hopefully now that makes sense, what the theorem actually says. And the reason I picked Thales' theorem is because, like I said before, a theorem is something that follows naturally from other things we know to be true. And the nice thing about Thales' theorem is that it's only based on things that are actually pretty basic that we've all been taught in school. And that's two facts. That one, an isosceles triangle, so a triangle with two sides of equal length, that's all an isosceles triangle is. An isosceles triangle has two equal angles inside of it. So it has two equal sides and two equal angles. And the second fact we're going to use is that the sum of the angles of a triangle is 180. So if you add up the measures of all the angles, you get 180. And that's actually all we need to prove the theorem. So hopefully you remember those facts, or at least believe them. Because if we're armed with those facts, we can then prove Thales' theorem. So for this proof, there's one essential thing we need to do. You remember before, right? We had these pictures, A, B, C, A, B, C. We're actually going to draw a line from this point O, the center of the circle, to B. And that new diagram is going to allow us to prove the theorem almost right away. So here is that diagram. You can see A, B, C, just as before. And we've drawn that line that I talked about. Now, the thing about these lines is, and this is the essential insight to prove the theorem, all of these lines coming from the origin all have equal length because they're all radiuses. So that's why I put this little dashed line here through them to signify that they all have equal length. And therefore, what we've actually done is broken our big triangle into two little triangles that are both isosceles. They have equal side lengths, right? And so as we said before, now these angles here, which I've labeled these two alpha, they must be equal because they're in an isosceles triangle. And these angles here must also be equal. I've labeled them beta. So just one more time, because that's the essential insight. So let's go over it once more. You break the big triangle into two little triangles that are isosceles. And now, therefore, because they're isosceles, we can say that this angle is the same and this angle is the same. We don't know what the angles are yet, but we do know that they're equal. And also, in addition to that, as we said before, the sum of the angles of any triangle is 180. And now we know that the sum of the angles of this big triangle is actually alpha, the measure of angle A, plus beta, the measure of the angle at C, plus alpha plus beta, which is the angle at B. So now we know alpha plus beta is this measure. So that's algebra. So we can actually write that as this. So alpha plus beta plus alpha plus beta is 180. And then just from simple algebra then follows 2 times alpha plus beta is 180, which means alpha plus beta is 90. Which means that this angle here, which again is alpha plus beta, is equal to 90. So it's a right angle. And therefore, we've proved from those two simple statements that we know to be true that Thales' theorem is correct. Any triangle that has that property we outlined before has to be a right triangle. So I hope you enjoyed that little proof that I've just outlined. The nice thing about proofs are that they can take seemingly boring mathematical facts and really show how they can be applied in sort of clever ways to prove something you might not expect to be true. So I think that's kind of interesting, and I hope you enjoyed it, and I look forward to hearing from you.